Next one more question, that's it. Okay, again, we're going to talk about velocity. Okay, so for number 2, if we know that a ball is thrown into the air so that its height in meters can be found using the formula H equals negative 2t squared plus 4t plus 48. Okay, I'm going to know how long to reach its maximum height, how long to reach maximum height. So how long does it take to get to the maximum height? I want to know what is the maximum height. So we'll just give you all the questions at the beginning here. How long to reach the maximum height? What is the maximum height? And how many seconds to land on the ground? So, if you wrote this as an ordered pair, okay, if I wrote this as an ordered pair, what is first? What is in the x position, the height or the time? What is in the x position here? The time. So this is time, comma, height. So essentially, how long to reach the maximum height? Oops, sorry, maximum height. I forgot the maximum part. Okay, maximum height will be what? Is that the x coordinate of the vertex or the y coordinate of the vertex? That is the y coordinate of vertex. I'm sorry, that's the x coordinate of the vertex. Sorry. Time, how long? We're talking about how long. Sorry. Time is the x coordinate of the vertex. What is the maximum height is which portion? The actual height is the y coordinate of the vertex. Sorry, I said that backwards just a second ago. So here, the first question is actually about the first thing you can find. Okay, so to reach maximum height, we would use x equals negative b over 2a, and we're going to plug in here. So negative times what's your b value? B value is 4 over 2 times what's the a value? Negative 2. So negative 4 over negative 4, that reduces to be 1. 1 what? 1 second. Okay, so how long does it take to get to the maximum height? 1 second. Okay, maximum height is at 1 second. Now, if you got a negative, would that make sense? It wouldn't make any sense. So if you got a negative somehow, check your work, because that doesn't make any sense. Now, what is the maximum height? How can I find the maximum height? Plug in. Okay, so plug into h equals negative 2 times 1 squared plus 4 times 1 plus 48. So work that out. Simplify negative 2 times 1 plus 4 plus 48. Leaves you with negative 2 plus 4 plus 48. Always go from left to right. Okay, so that's positive 2 plus 48 equals 50, and this is 50 what? This is meters, okay, because we said that this was in meters earlier. So what is the maximum height? Maximum height is 50 meters. Now, how many seconds until it lands on the ground? What are we finding here? How many seconds until it lands on the ground? What are we finding? What is that in terms of a parabola? The x-intercepts, okay? Really, we are trying to find the x-intercepts here. Now, a lot of people will generally just double the time, okay? I'm doing this on purpose because it does not just double, okay? So essentially we're gonna set this equal to 0. So 0 equals negative 2t squared plus 4t plus 48. And that makes sense. The ground would be at 0 meters, 0 feet, okay? Factor out a negative 2, that's your GCF. Left behind we would have t squared minus 2t minus 24. So 0 equals. Factor again, so negative 2 equals, multiplied by, if you factor this, this is t minus 6 and t plus 4. Break these apart. Positive 6 or negative 4. Does it make any sense that it would cross the ground at negative 4 seconds? No. Okay, if you drew this picture, this parabola is off center. Okay? So this parabola has x-intercepts at negative 4 and positive 6. So when will it hit the ground is 6 seconds. And the reason this works is, what if I threw it off a building? Okay? If I didn't start on the ground. Never said I started on the ground. Okay? So I have a building. My little stick figure person, I throw this off a building. Oh, look, it goes barely up and then all the way down. Okay? That's why that could happen. Okay? So do not always assume that you can just double. Okay? That would be incorrect. Homework for this objective is worksheet 7, numbers 1 through 8. Okay, there's only 8 word problems. Please show your work as much as possible. Okay, please, please, please. And we will start reviewing tomorrow. Okay?